Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on equilibrium and couples. So far, in our lessons about equilibrium, we have learned that equilibrium results from a net force and net torque of zero acting on a body or particle. Today, we will learn about forces called couples and the effect that couples have on a rigid body. A set of forces with a resultant moment but no net force is called a couple. A couple can also be explained as two equal and opposite forces acting on a body. We can compare couples to the forces we have previously studied by looking at the following examples. In this figure, the forces are equal and are moving in the same direction, but they are producing torque in opposite directions. In this figure, the forces are equal and are moving in opposite directions, but they are producing torque in the same direction. This is a couple. Earlier, we learned that the moment about a point varies depending on the point around which we choose to take the moment. Students, let us solve for the moments about three separate axes to see if the same is true for couples. In this example, we have three axes, A, B, and C. We have two forces, F and negative F. Students, please solve for the moments about A, B, and C. Remember to solve for both clockwise and anti-clockwise moments in order to calculate the net moment.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Well done, everyone. What were your results? Let us quickly solve the moments together. For the moment about A, our formula says that A equals negative fx plus f times x plus d equals fd. For the moment about B, B equals fy plus f times d minus y equals fd. For the moment about C, C equals negative f times d plus z minus fz equals fd. What have we learned, students? We have learned that when it comes to couples, the moment is independent of the axis we take the moment around, as long as the axis is perpendicular to the plane of the couple. In other words, our axis can be any point along the plane. The force of the couple will remain constant. These are the properties of a couple. The linear resultant of a couple is 0. For example, f plus negative f equals 0, and the moment of a couple is not 0 and has the same magnitude irrespective of the position of the perpendicular axis chosen. There are many examples of couples at work in our everyday life. Did you know that every time you turn on a water tap, the forces used to turn the handle are a couple? Students, it is time for our next activity. What other examples of couples can you think of in everyday life? In small groups, please discuss these examples and share them with the rest of the class.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. I am sure that you came up with some wonderful examples. Some examples that I thought of are windmills, steering wheels, and this. A Ferris wheel is a great example of the rotational effects of couples on the rigid body. Equal forces are pushing in the same direction around the axis and are keeping the wheel in constant motion without the wheel actually going anywhere. Every force must work together to maintain equilibrium. Just think what could happen if the net force and net torque in a Ferris wheel did not equal 0. Equilibrium keeps the people on the ride safe. Today, we learned that two equal and opposite forces acting on a body are called a couple. We also learned that although a couple has no net force, it does have a resultant moment. The torque of a couple is found by multiplying the force by the distance between the forces. You can find examples of couples in many everyday objects, particularly those involving rotation. Remember this lesson the next time you turn on the water. Until next time, thank you, teacher. Thank you, students.